as we're discussing about the properties of colloidal solutions. Okay, this is the second property, which is mechanical property and is known as the Brownian movement. Now see, Brownian means it's come from a name of a scientist, which is Brown. Okay, Brown observed with the help of microscope that the particles of the colloids are in the randomly moving in a zigzag motion, and this random zigzag motion is known as the Brownian movement. Okay, this zigzag motions is mainly due to the bombardment of the dispersion medium. Now, what is bombardment? Simply, bombardment means dhakkamukkhi. Okay, suppose these are the molecules. Suppose these black molecules are the dispersion phase. Okay, and blue molecules are the suppose dispersion medium. Since the dispersion medium is in large amount, that's why the collision between this dispersion mediums is rapidly observed. Okay, these collisions between the dispersion medium, or you can say this particles of dispersion mediums collides with the dispersed phase. That means ये डिस्पर्शन मीडियम का जो पार्टिकल होगा वो डिस्पर्स्ड फेस का जो पार्टिकल होगा उसके साथ भी वो धक्का मुक्की करेगा. ये धक्का मुक्की के वजह से दैट मीन्स वो जिगजैग मोशन में आने की वजह से जो मूवमेंट होगा वही होगा ब्राउनियन मूवमेंट. ओके, चार्ज ऑन कोलोइडल पार्टिकल्स. ओके, remember colloidal particle is stable due to its charge. Okay, without a charge or without any charge on a colloidal particle is not so stable. Okay, now see, the charge on colloidal particle is mainly due to two reasons. First one, the electron captured by the solid particle during electrostatic dispersion of metal. Electrode dispersion of metals means when electrode is dispersed, that means electrode is heated, it produces some vaporized atom from this vaporized metals. When it is condenses, it produces electron, or you can say which electron is captured by the colloidal particles, resulting the charge on the colloidal particle. Okay, now see, second type is the preferential adsorptions of the ion from anion or due to the formation of electrical double layer. This one is the main important or main responsible of the charge on the colloidal particles. The preferential adsorptions from the ion from solutions. The preferential adsorptions of ion from solutions. That means from the solutions, one of the component of colloidal solutions will adsorb the another ion, or oblique and due to the formation of electrical double layer. Now see, what is the electrical double layer and how ions are absorbing by the colloidal particle. Okay, now see, this one is very important. Okay, now see, we have taken an example. Example is when silver iodide is added to, this one is a compound, this one is another compound. Okay, this one is the dispersed phase and this one dispersion medium. Okay, remember here the reaction between, or you can say the formation of colloidal particle between silver iodide and potassium iodide may be in two ways. First one we are giving as when silver iodide is added to potassium iodide. silver iodide is added to potassium iodide. Another is potassium iodide is added to silver iodide. Okay, potassium iodide is added to silver iodide. Now see how. Due to this common ion here, the silver iodide is surrounded, or you can take takes. It is surrounded by I negative ion. That's why I'm saying no. This adsorbed ion, and the potassium positive remain in this side. In this way. But here is just opposite of this one. This one, silver iodide is surrounded with potassium ion. Potassium ion, here is I negative. Now see, if you see silver iodide is a colloid, silver iodide is surrounded with negative charge. That's why it is negative colloid, or you can say negative charged colloid. But this one is surrounded by positive ion. That was positively charged colloid. Now see, as you can clearly see here, one is positively charged, another is negatively charged. Layer is there. This layer is suppose negatively charged, but this layer is positively charged. Due to this charge differences, or you can say the separation of two charges, this is known as electrical double layer. This is the positive layer, negative layer. This is a positive layer, and this layer is known as electrical double layer. Electrical double layer. Another thing. This layer is fixed, no, because the colloidal particle is surrounded with the negative ion. That's why it is fixed. Is known as fixed layer. Okay, I shall give you the written notes, or you can say diagram how to write. Okay, these are simple explanations. This layer is fixed layer, but this is mobile layer because the positive ion is moving within the dispersion medium. Okay, that's why it is mobile layer. Similarly here also, this one is fixed layer. This one is mobile layer, and this one is electrical double layer. Okay, electrical double. Now see, here's the two opposite charges. No, if two opposite charges is there, then obviously for the individual negative charge and individual positive charge, some potential also be there. That's why the difference between this opposite charge, that means the difference between the potential of the negative charge and the positive charge is known as the zeta potential. Zeta potential means the difference in the potential of the individual charges. Okay, and if zeta potential here also, this one zeta potential, and zeta potential has another name also, which is known as electrokinetic potential. Okay, next properties is the electrophoresis. Okay, now electrophoresis is the movement of colloidal particle towards the opposite charged electrode under the influence of an electric field. That means, suppose here is a you taped any container, okay, where there is a electrode which is supposed negatively charged. Here is another electrode, suppose it is positively charged, is connected through any battery or electricity. Okay, now see, this one is negative charge, here is positively charged, here is dispersion phase and dispersion medium is there. That means a colloidal solution is there. When the electricity is on, it means when starts the electric current flowing to that electrode and the circuit, the positively charged colloidal particles are moved to the negatively charged electrode, and the negatively charged colloidal particles moves towards the positively charged electrode. And this process of movement of colloidal particles towards the opposite charge by the influence of electric field is known as the electrophoresis. Okay. Now here's another phenomenon which is known as electroosmosis. It is simply the opposite of electrophoresis, when the movement of particle is prevented by any kind of means. When the particle movement is somehow we have prevented, okay, then it is observed that the dispersion medium begins to move towards the electrical field is known as the electroosmosis. When the movement of particles is prevented, then the dispersion medium is started to move towards the electric field, and this process of movement is known as the electroosmosis. Okay. Now see the next topic. Next topic is the precipitation and coagulation. Precipitation and coagulation. Now see. Next topic is the precipitation. Precipitation and coagulation. Okay. Now what is precipitation and coagulation? Precipitation and coagulation are the same thing. Okay. You can write or also here. Precipitation or coagulation. Precipitation or coagulation is the process of changing the colloidal particle into a insoluble precipitate by adding the small amount of electrolyte. Now see, let us take an example here. We have taken as a colloidal solution of suppose milk. Milk is a well-known colloidal solution, no? When we add HCl, HCl is electrolyte. When we add HCl, obviously milk we transferred into curd, no? Then we produce this one. This one is the liquid part. This one suppose curd. The lower portion suppose curd. Curd means what? It is insoluble. Insoluble. This formation, suppose when the milk is in colloid, is transformed with the help of HCl to a insoluble compound, which is a suppose this one curd, and the process of converting this insoluble PPT or curd is known as the what? Precipitation or coagulation. Okay. Theorem or well-known rule of Hardy-Schulze rules on the coagulation or precipitation of an colloid. Okay. Now see, here are the two rules. Okay. First rule is the ion carrying of the charge opposite. Okay. The ion which is carrying an opposite charge to the colloidal particle of immense small particle is only effective to precipitate or coagulate. That's why I'm written the ion carrying the charge opposite to that of the small particle are effective to causing coagulations. Okay. अगर वो colloid के opposite charge ही होगा, अगर colloid plus हुआ तो चार्ज जो आयन कैरी जो इलेक्ट्रोलाइट जो चार्ज होगा वो नेगेटिव होना पड़ेगा, अगर अपोजिट हुआ फिर ही वो इफेक्टिव कोगुलेशन कर पाएगा, बढ़ना नहीं कर पाएगा. Okay. Now second is the coagulating power of electrolyte is directly proportional to the charge. It may be positive or it may be negative. Now see, the larger the charge, larger the coagulating power. It may be positive or negative. Now see, for the cation, it is observed that aluminum 3 positive has larger coagulating power than the magnesium 2 positive, which is larger than the sodium 2 single positive. Due to the increase in charge, there is a larger coagulating power. This one 2 positive, 1 positive, this is single positive. Now similarly for the anion also, larger the charge, larger the coagulating power. Here it is plus minus 4. Here it is minus 3. Here is minus 2. Here is minus 1. See, number of charges, that means negative charges, is decreasing in this way. That's why their coagulating power also decreases from 4 negative to single negative. Okay. Now see next topic is the protection of colloid. Protection of colloid. How it is. How it is. Protection of colloid. As you know, lyophobic colloid are less stable because of weak interactions between the dispersion phase and dispersed phase and dispersion medium. Lyophobic means which repels the solvent or liquid. That's why it does not interact with the dispersion medium and becomes weak. Okay. Now see, weak means less stable. Now see how. Lyophobic colloid are less stable because of weak interaction between the dispersion medium. Okay, dispersion medium. Now, to stabilize or to protect this lyophobic colloid, we have to use or we have to add some other colloid also. Now see how. To protect the lyophobic colloid, that means to stabilize the lyophobic colloid, lyophilic colloid such as stars are added or you can say used. Okay, which, because as you know, stars is a stronger affinity for the dispersion medium as stars has stronger affinity towards dispersion medium. See, stronger affinity means the stars molecules or stars particle loves the dispersion medium, that means liquid. That's why when we add stars, okay, to the lyophobic colloid, it is stabilized with the help of stars, because stars is a solvent loving particle. Okay, that is lyophilic, isn't it? No, that's right. Okay, next is the emulsion. What is the emulsion? Emulsion is the colloid in which what? Both the dispersion medium and dispersed phase are liquid. Okay, now see how. Emulsion. What is emulsion? It is the colloid in which both the dispersion medium and dispersed phase are liquid. Okay, simply emulsion means dispersed phase and dispersed medium or liquid. Now it is of two types. Okay, it is of two types. First one is the oil in water. Second type is the water in oil. Now for better explanations, or for better remember, we can write this way: O oblique water. Water in the water. W means water. What oil in water. This one water in oil. Okay. Now see. Here water is dispersed phase, and this oil is dispersed phase and water is dispersion medium. And similarly here also water is dispersed phase and oil is dispersion medium. Okay, now what it is example? One of the well-known example is milk, where oil means fat, proteins. These are the dispersed phase in the milk, and water, that means water is the dispersion medium. Here also, here if we take the example, then suppose butter. Okay, this water in butter, no, some water component is there because it is made up of milk. This water in the butter is the dispersed phase, which is in very less quantity, and the oil, that means the, you can say fat, that means say vegetables, oils and other oily substances, are the dispersion medium. That's why it is water, and in water in oil emulsions, where the water is dispersed phase and the oil part is dispersion medium. Okay, now see the next topics or next concepts of emulsions. Written, no? That's right. Okay, now see. Emulsion is less stable. Emulsion is less stable. Okay, therefore a third party, or you can say component. Okay, third component is introduced to stabilize the emulsion. Okay, introduced into the emulsion, to stabilize. Okay, these components are known as stabilizing, or you can say emulsifying agent. Okay, these components, or you can say component or agent, are known as emulsifying agent. Why it is as an agent means it stabilizes the emulsions. Okay, it stabilizes the emulsion. That's why it is emulsifying agent. Okay, now what is the example? Suppose example, well-known example is the protein, gum, okay, soaps, etc. Next is the de-emulsification. Okay, de-emulsification. Written, no? Next topic is the de-emulsification. De-emulsification. Now, what is de-emulsification? Okay, de-emulsification is the separation. The process of separation of the two components of emulsion are called de-emulsification. Okay, see, it can be done by centrifugation or freezing. Centrifugation or freezing. Okay. Now, what is centrifugation? Suppose, let us take a test tube. This one. Suppose this one is a test tube where we have taken emulsion. Suppose oil and water. Simple emulsion. Now, when we rotate this test tube having emulsion in very high speed, okay, in very high speed, then the particles of oil and water separated out. That means the heavy particle will settle down and the lighter particle will floating on the upper portion of the heavy particle. Okay, by this way we can separate the emulsion into their respective particles. Okay, the next, no? Next is the application of color. Last topic of your chapter. Application of color. This one is homework. Please go through the book, and lots of application is there in your book. Okay, remember, from the applications, one short questions may come. It's very important. That means how skies imparts the blue color and some other examples also. Okay, thank you. And from the next week, that means from Monday, we'll start about the 6th chapter. It is the general principle of instruction of some metals and ore. This. Okay, thank you.